We've just finished looking at several topics, including simplifying, multiplying and dividing rational expressions, and adding and subtracting rational expressions. For both introductory and intermediate algebra students, now what I'd like to look at is solving rational equations. For the introductory students, this is the topic that comes next in your course. For intermediate students, please be aware this is not the next topic that you'll see in the chapter, however it is in the same chapter. What I'd like you to notice, the difference here between the 5 operations that we did, actually 4 operations in simplifying previously with rational expressions, is that now you're going to get a solution for the variable x or y or whatever t, whatever letter we use. So now you are looking for strategies in order to solve an expression that has an equal sign. Please remember that the last 45 minutes worth of video have all been expressions. None of them have had equal signs, and all you've been doing is the process of multiplying, dividing, adding, or subtracting. Again, now I'm looking for solving for this letter t in this expression. However, I'm going to use some of the very same steps that I've used when I added and subtracted rational expressions, so be careful. Your first step, and again, you need to be looking under the assignments area and in Course Compass and look at the supplementary material that I've provided you, or I might have called it very important material from your instructor, and look for the solve rational equations topic. The first step is to get a common denominator between this 8, this 3, and this 12. And in this case, that's going to be a 24. Again, you know how I like to write that off to the side so that I remember what I'm working with. Unlike where, when we added and subtracted expressions, we wanted to get a 24 in the denominator, what I'm going to do now is I'm going to multiply both sides of this equation by 24. This one time, and this one time only because I'm going to run out of board space is the only reason, I'm going to show you that I'm going to multiply by each side by 24. And also one time only, I'm going to put a 1 underneath that 24. And the only reason I'm doing it is to force you to keep that 24 up high in the numerator. I want to multiply both sides of the equation by that 24. What that ultimately means, however, I'm just going to copy the original expression here. It ultimately means on the left-hand side here, multiplying the 3/8 by 24 over 1, and multiplying the 1/3 by 24 over 1. On the right-hand side, it means taking that t over 12, like I've already shown, and multiplying it by 24 over 1. Again, would you please notice that every term got multiplied by 24. It didn't get multiplied top and bottom by what was necessary to make this denominator become a 24. Everything got multiplied on top. And here's the reason for that. If you multiply every term by 24, then you're guaranteed, since this is a multiple of 24, you're guaranteed that it can be reduced. 8 goes into here once, and 8 goes into here 3 times. And what you have left right here in this expression is 3 times 3, or 9, over 1. I'm not going to put the 1 down there. My goal is to get rid of the denominators. In the second fraction here, I'm guaranteed that 3 will divide evenly into 24, in this case 8 times. And 8 times 1 is 8. And then finally, on the right side of this equation, I'm guaranteed that 12 will go into 24, in this case 2 times. And again, I'm left with 1s downstairs, and I have 2 times t in the numerator. This is a slick process because by multiplying by the least common denominator, you get rid of the denominators. You have 1s left, and you have a simple linear equation, or possibly you'll have to solve it by factoring, but in this case, a linear equation that you solve by, in this case, finally, dividing both sides by 2. My answer for this problem is t equals 17/2, or if you wanted to go ahead and call that 8.5. I should be able to take that 8.5 and plug it in for t right here and check it and see that it works in this equation. Again, our goal is to solve rational equations here, not to get common denominators. Our goal is to find out what t is equal to in the end. I'd like to solve this rational equation. Again, you've got to watch the directions. I'm going to ask you to solve the equation, and also you're going to notice that there's an equal sign. And what you're going to do then is you're going to look at these denominators. You're going to say, I need to decide what the least common denominator is between all 3 of these. This factored form is 3 times y. Here's a y as a factor, here's a 3 as a factor. My LCD, as a result, is just that 3y. And so, again, if you would please remember This is hard for people. They want to fight this. If you would multiply every term by 3y on the top only, getting a little sloppy here, and then I'm wanting to fit it in right next to each term. And when I do that, then I get to remove the common factors that exist. So 3 goes into here once and into there once, and y goes into here once and into here once. I didn't cross those off in one fell swoop because I wanted you to see that those were factors, because I want you to see that this y and that y can be removed because it's 3 times y, that's why I can remove it. And here this 3 and that 3 can be removed. And what I'm left in this first term right here with those 3 y's being canceled out, I'm left with a 4. With these y's being canceled out, 3 times 3 is 9. And then here with the 3's being canceled out, y times 10 is 10y. I'll go ahead and subtract the left-hand side. 4 minus 9 is a negative 5. And finally, I'm just going to divide both sides by 10. And I'll have y equals a negative 1/2. Again, I should go in and check it. I'm lacking board space and running out a little bit of time. So you should take that answer and make sure that it works in these expressions. This is a special situation of solving rational equations. The difference between this one and the last few that we've done, and some others that we will do in the future, is that on the left side I have one fraction, and on the right side I have another fraction. This is called a proportion. A proportion is 2 ratios set equal to one another. I'd like to remind you of something that's true about proportions, and I'm just going to share a different example with you. The fraction 2/4 can be reduced to the fraction 1/2, and should be for that matter. This is another example of a very simple proportion. 2 ratios set equal to one another. And one of the properties of proportions is that their cross products, or the product of their extremes, right here, will always equal the product of the means. Again, the cross products. And you'll see here that this 2 times 2 is equal to this 1 times 4. And that property can be applied with rational equations as well when you have a proportion. So what I'd like to do here is I'd like to apply that principle, and I'd like to go ahead and take this times that 7. I'll write it like this: 7 times x minus 6. And then I'll let it equal the 2 times the other product over here, times the x plus 9, and I've gotten rid of the fractions. Again, that's the goal here, is to get rid of fractions so I can solve for x. Let's finish this one up. So here I'll have a 7x minus 42, and here a 2x plus 18, and I think I'm going to choose to subtract 2x from both sides. I'm following through with this because you haven't seen a video on this topic at all, although it was some time ago. Let's add 42 to both sides. And so we have 5x on the left, and this adds to be 60. And now we'll divide both sides by 5. And I find out that x equals 12. Again, should go back in and check it. I might even be able to do this one fairly quickly. 12 minus 6 in the numerator is 6. And 12 plus 9 is 21. This side right here, this fraction, is equal to 6 over 21. Just ask yourself, is that equivalent to 2/7? It sure enough is, because 3 goes into here twice, and 3 goes into here 7 times. And we have proven that x is equal to 12. Solving a proportion that was a rational equation that was a proportion is kind of interesting and quite quick. We're back to looking at a problem that is no longer a proportion. Let's follow the directions that we followed a bit ago, which was to look at this expression, this equation, and look at the denominator and decide what the LCD is. Well, this one's awfully simple. There is only one denominator, and so the LCD is y. So what I need to do is I need to multiply every term in this equation by y, both sides basically. Again, I'm not showing that initial first step each time. I'm going to multiply this by y, I'm going to multiply this term by y, and I'm going to multiply that term by y. Please remember to multiply every term by y. And in doing that, again, my goal is to remove that denominator, which will most certainly simplify when I've multiplied it by the LCD. What I'm left with, however, right here, and this is what people often forget, is they forget to multiply this y by that y. I have a y squared term, and then I have this 22, And then over here I have a minus 13y. Well, it's been a little while, not too long, where we've solved an equation that had a variable raised to the second power. And we did that by using the zero product rule. Remember, the zero product rule said that you should get everything on one side of the equation, get 0 on the other. So I'm going to transpose, if you'll allow me to do so. I'm going to bring the minus 13y over to this side. I am basically adding 13y to both sides. I'm just not going to show the step. And I'm doing it because I want 0 on one side so that I can factor this left-hand side. It looks like it's going to be y plus 11 and y plus 2 because I need two numbers whose product is 22 that adds to be 13. And remember, the zero product rule just says to take those factors, y plus 11, set it equal to 0, take the y plus 2, set it equal to 0, and solve these for y. Here I would subtract 11 from both sides. So one of my solutions to this problem is a negative 11. And here I'll subtract 2 from both sides. And the other solution is a negative 2. Again, you should check them back in the original equation, which read y plus 22 over y equals a negative 13. Check the individual solutions separately to be sure that they work. This is the last problem that we're going to solve in terms of solving rational equations. And please remember, we've been working with rational expressions and rational equations. The word rational means that I can express this as a fraction. And we've been working with fractions, as you can see. We are solving an equation, which means that we need to find the common denominator. So remember, back to adding and subtracting, you have to factor everything first. So here I'll take a 2 out. This denominator needs to be factored into x plus 5 times x minus 5. And this denominator cannot be factored at all. So I'll put parentheses around it. My LCD as a result, take every factor the greatest number of times that occurs in any one. So I need this 2. I need an x plus 5. It occurs once here and it occurs once here. I need it one time. I need an x minus 5 because it occurs at most once in either of these. So my LCD is the 2 times the x plus 5 times the x minus 5. Now I'm going to see if I can squeeze this in and see that it doesn't cause us any grief. And so what I'm going to do is I'm going to show the process of multiplying each one of these fractions by that common denominator. I actually believe I'll go ahead and recopy. So I have 1 over 2 times x plus 5. It needs to be multiplied by 2 times x plus 5 times x minus 5. Then I have the equal sign, and the 8 over the x plus 5 times the x minus 5 also needs to be multiplied by 2 times x plus 5 times x minus 5. And finally, this minus 2 over x minus 5 needs to be multiplied as well by 2 times x plus 5 times x minus 5. Again, I'm multiplying numerators only, and the reason I'm doing it is so that I can get rid of the denominators. And I'm guaranteed that if I multiply every term by the LCD, then I can get rid of these denominators. Notice here, these 2's, they simplify, they're equal to 1. The x plus 5's will cancel out. All I'm left with in this expression right here is the 1 times the x minus 5. I'm not even going to bother with the 1. On the right side of the equal sign, I get to cancel out this x plus 5 and that x plus 5, this x minus 5 and that x minus 5. Again, I wanted to get rid of the denominators. All I'm left with is 8 times 2, or 16. I'm going to bring my minus sign down so I don't lose it right here. I'm going to cancel out this x minus 5 and that x minus 5. So what I have left right here, I'm going to be very careful. I have this minus 2 times 2, or 4, times x plus 5. And so I'm going to go ahead now and I'm going to distribute this. So I'll clean this up. I just have a linear equation now. A minus 4x here and a minus 20. I'll bring down the 16. Please remember when you solve a linear equation that you should combine your like terms on one side of the equal sign. So the 16 minus the 20 is a negative 4 minus 4x. And I'm going to go ahead and add 4x to both sides. I might have enough room. And because of space here, on top of that, I'm going to have my x terms over here. So I'm going to add 5 to both sides as well. And so I will have here 5x, and a negative 4 plus 5 is 1. Again, if 5x equals 1, then finally I'll divide both sides by 5, and I'll find my solution, x is equal to 1/5. Again, put it back in everywhere you see x and check it in this expression. There's one last thing I'd like to mention about rational equations. If you don't do that check at the very end of a problem, there are some circumstances where a solution that you will get will cause the denominator to be 0. And when you go to check it in these expressions, when you try to divide by 0, you have to stop and put the brakes on and say, I can't do that. I can't divide by 0. So let's say that this particular problem gave us an answer of 5 instead of 1/5. If one of the answers were 5, look at what would happen when you try to check and put a 5 in right here. 5 minus 5 is 0. You can't take 2 and divide it by 0. So if an answer of 5 had come out here, and that's all that had come out, you need to tell me that there's no solutions to that equation. Not only does it not check here, it doesn't check here as well. 5 squared is equal to 25. Minus 25 will give you 0. And over here it would have been okay. But again, solving rational equations, you can be sure that I'm probably going to ask you a problem where you get an answer that if you don't check it and check to see if the denominator turns out to be 0 and tell me there's no solution, you're going to have some trouble. For introductory algebra students, this is the conclusion of the chapter about rational expressions and rational equations. Intermediate algebra students, there's going to be more material to follow, and I'm going to follow with videos.